Hello everyone, welcome back. Myself Rahul. So today we are going to solve a problem related to strings. Problem name is longest palindromic substring. Let's go through the problem. So problem statement is very small. Given a string S, return the longest palindromic substring in S. So palindrome is basically a string in which if we go from the front of the string or via the back of the string looks same. Right, so given this string BABAD, what is the maximum length of palindrome over here? So BAB is a palindrome because if we start from the beginning of the string or from the end of the string would look same. So it is the largest palindrome in this given string. So we have to return the longest palindromic substring in S. Basically the length of there can be multiple palindromic substrings in the given string, but we have to return that particular substring which has the maximum length. So how do we approach this problem? So if we go by the brute force method of this problem, so what can be the brute force approach? So let's take an example to understand this. So let's take a string called A, B, D, D, B, A, D. Right, so brute force method would be like we generate all the possible substrings of this particular string and check whether this particular substring is a palindrome or not. Right, so what are the ways in which we can generate all possible substrings of a given string? So suppose string size is n, so we need to run two loops, and using those two loops I can generate all possible substrings. Right, so I can have two loops I and j, and this I loop can start from 0 to n and j can start from I to n. Right, and I can take the basically the substring between them. So if I have a substring with me, suppose this is the substring, right, of the given input, I need to check whether it's a palindrome or not. So a string to be a palindrome or not, how do we check that? We can start basically one pointer from the beginning of the string and one pointer from the end of the string, right? And we just compare whatever element is present at here, over here, and over here. If they are same, then we will increment this pointer by 1 and decrement this pointer by 1. And we keep on doing this till the elements are same. And if we somehow reach the end of the string, this substring, it means it's a palindrome, correct? So we had n square number of strings with us, and to check whether a single string is palindrome or not, we need on time. So what is the total time complexity for checking for getting the largest possible substring which is palindrome is n cube, because n square is the number of substrings generated, and for a particular substring we would take around O of n time to check if it's a palindrome or not. Right, it's a brute force method. So let's see if we can somehow optimize this approach. So other approach for this problem would be using the dynamic programming, which is my personal favorite as well. So let's see if we have a given problem. Let's take this example only, or maybe in general string. So suppose this is a string over here we have, right? This is a string. So suppose we want to know whether this string is a palindrome or not. So what are the ways we can check it? Right, so one of the ways we had checked it is like in the previous approach, brute force method. The other approach can be like if we have this big string, and if we have if we basically want to add another character to this string in the end, we want to know whether this complete string would be a palindrome or not. Right, so dynamic programming comes into picture over here is like if we have the somehow knowledge of all the substrings of this part of this string, if we have the knowledge of this substring, like what all parts of this substring are palindrome and what are not. Taking an example A, B, D, let's suppose D over here, B, uh, let's suppose A over here, right? So it's a substring, correct? It's a palindrome, this substring, right? So we somehow maintain that string starting from this particular index, So if we have somehow knowledge that string starting from this particular index I to this particular index j, so I to j, if this string is palindrome, we somehow maintain that this is string is palindrome, so we maintain it by variable suppose 1. So now if the other variable comes, so suppose this is also a, right? We need to check whether this complete string would also be palindrome or not. For this complete string to be a palindrome, one basic condition that it needs to fulfill is the first character and the last character has to be same. Correct? So A and A are same. So let's ignore these. So now we need to have this knowledge as well, whether this part of the string is palindrome or not. So string present between I plus 1 to jth index, whether it's a palindrome or not. So suppose we also maintain this information, like we already have this information with us, that substring present between I plus 1 to jth index is not a palindrome. So we mark it as 0. So obviously the string present between I to this new index k, I to this new index k would not be a palindrome, right? It would be marked as 0. Right, so how do we maintain this? So for this, we need to maintain all the possible substrings values, whether a particular substring is a palindrome or not. So for this, we will require a 2D matrix. Let us build one. In this, A, B, D, D, B, A, D. Let's take this example. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 and 7. Right, so let's mark it over here as well. Right, so this is the ith index from where the substring is starting, and this is the jth index from where the string is ending. So basically we are considering the string between I to jth index. So it means the string is starting from A over here and ending at A. It is a palindrome, yes. So obviously the diagonal elements would always be 1. So it is 1, it is 1, 1, 1, 1 over here, 1 over here. And did I missed anything? D, 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 B, B, A, and not over here. This is also 1. Right, so we can ignore this part of the string, this part of the matrix, because obviously I obviously has to be greater than j. Right, so considering A to B, which means string is starting at A and ending at B. So for this to be palindrome, A and B obviously has to be same, but they are not. So which means string starting at A and ending at B would not be a palindrome. So we would mark it as 0. Similarly, we will consider B and D over here, which is B is not equal to D, which result in 0 over here. Similarly, D and D, right? So D and D. So D and D are same, and therefore I would mark it as 1 over here. Similarly, D and B, which are not same, 0. B and A 0, and A and D, this is also 0. Correct? Now I am going to populate this part of the matrix. So string starting at A and ending at D. How do we populate it? String starting at A and ending at D. This A and this D. So A and D should have been same if this string was a palindrome, but it is not, so it would mark it as 0. B and D would also be 0. D and B, it is also 0. D and A, this is also 0. Similarly, this also 0. So basically we are taking all the substrings and we will keep on populating this diagonal matrix and keep on incrementing our value by 1. Right, so in this process we will maintain what is the maximum length of the substring which we have encountered till now. This is also one of the possible approaches to this solution, and the time complexity for this would be O of n square, and the space complexity would also be O of n square, because we are using an extra space over here in the form of a matrix of n square size. Let's try to see if we have a better approach to this problem apart from the O of n square approach. Yeah. So if we observe a palindrome carefully, suppose A, B, D, D, B, A, D. So suppose a string is a palindrome. So what we can definitely make sure is if we have somehow know the center of that particular string, right? So the character present to the left of the string and to the right of the string would be same, right? So suppose A, B, C, B, A, right? So suppose this is the center of the this palindrome. So character present to the left of this center and to the right of this are obviously same. So if we have two pointers with us, I and J, we have I point to the left of the center and J to the right of the center, and we will keep on decrementing I and keep on incrementing J till those values are same, right? So this is an approach which we can use over here. We have how many centers in this particular string? Suppose that this string size is n, so every element can be considered as a center, right? So we would have n such centers. So suppose this is one of the centers, this is one of the centers, and we can basically start I from here and J from here. Similarly, this B can also be a center and center of the longest substring, right? Here as well, two possibilities arises, like the largest palindrome we are looking for, whether it is of an odd length or even length. So in this case, it was of an odd length, so the center of the palindrome is just one, A, B, C, B, A. So C is the center. But what if the center are two? So in this string, we can't have a single center, right? So these two are actually both the centers of the largest palindrome over here. Right, so let's try to code this problem. Basically, we have understood like how the approach would look like. Like we would consider every element in the input string as a center and try to expand in both the directions, left and right, until we have the elements similar at the ith and jth index. Right, so every element will be considered as a center, and we will keep on maintaining the largest substring we have encountered till now. So let's try to code this problem. So we have the substring string s with us. What we need to do is we need to run a loop till the last index of the array of the string, and every element of this string would be considered as a center one by one, right? And if a particular element is a center, we need to maintain two variables I and j, and we will keep on decrementing I and incrementing j such that the values present at ith and jth index are same, right? So what I am going to do over here is I need to write one function which is going to return me the length of the substring if I is considered as a center. So I is center of the palindrome. Let's assume it, right? So get length. If I is the center of that palindrome, so what is the length of the palindrome? Let's see. So I will pass, let's call it str only. So I'm going to pass string over here and I as well. And I'm going to pass I two times. I will tell you why. So as I told you earlier that we can have two kind of possibilities if a string is palindrome, right? So string can be of an odd length or an even length. Okay. So if it's an odd length, so I particularly is over here, and we need to basically this is just a single center, right? So let's call centers as x and y. So over here, x is also I and y is also I. And if there are two centers, so centers are denoted by x and y. So x over here is I is over here, and y would be I plus 1. That's why I'm passing two variables over here. So int L2 would be the case in which there are two centers, str and I plus 1. Right, so let's write this get length function. It is going to return me a int So it's passing string over here, and I will pass start int end, or maybe I can name it as left. This one is right. Right, so what I'm going to do over is I'm going to write one loop so that we keep on iterating over the left and right part of the string continuously, right? So while left is greater than equal to 0, obviously we don't have to cross the limits of the string, and right is less than str dot length, string dot length. Yes, it is less than length, and str of left should be equal to str of right, correct? So in this case we will keep on decrementing left pointer and keep on incrementing right pointer till this condition is valid. And if this condition is not valid, let's see what will that case be. So suppose a b c b a, I started from here, so I is over here, so start would call it 0 1 2 3 4. So start would be 2, end would be 2. I'm going to compare start and end, so both are same in this case. So I'm going to decrement start, so start comes here, start becomes 1, end becomes 3. So I'm going to compare this b and this b, they are same. Start becomes 0, end becomes 4. 0 and 4, this a and a are also same. Start becomes -1 and end becomes 5. Right, so what is the length of the string I have to return? It would be end minus start minus 1, which is 5 minus -1 minus 1. 5 plus 1 6 minus 1, it is 5. So I have to return end, it means right minus by end and start, I means right and left respectively. Right minus left minus 1. It is the length of the string, longest palindrome string, if I is the center. Same is the case with if we had a even length palindrome. So that would have been in the case L2. Let's see, I also need to maintain two variables. Start is equal to 0 and end is equal to 0. So these are the indices which are going to tell me what is the starting point and the ending point of the largest palindrome I have encountered till this particular moment. Right, so they are initialized to 0, which means I haven't encountered any palindrome yet. And here I'm going to check if L, yeah, I need to compute the maximum of these two values and compare that maximum value with the maximum length of the palindrome till now. And what is the maximum length of palindrome till now? It is end minus start plus 1. If it is less than max of L1 and L2. Let's create one more variable for the sake of simplicity. L is equal to max of L1 and L2, and let's compare that with L. Yeah. Yeah, so end minus start plus 1 is nothing but the maximum length of palindrome I have encountered till now, and L is the maximum length of palindrome if I is the center. So if I is the center and the length of the palindrome considering I as the center is greater than the length of the palindrome till now, so I have to update the end and start indices, correct? So how I am going to update? I have to basically first check here if the maximum length has come from considering I as the center of the even substring or odd substring. If L is equal to L1, which means the maximum length of the substring is of odd length, right? So in that case I have to update the start variable. So what will be the start in this variable? Sorry, yeah, so here I can see I is over here, and length would be 5, I is equal to 2, right? So I have to update the start variable as this index 0. What is the 0 index value will be over here? It is I minus L by 2, which would come out to be 2. 2 minus 2, yeah, I minus L by 2 basically, right? So start is equal to I minus L by 2. Otherwise, the start would have to be updated as, it means L is equal to L2, which means the maximum substring, palindromic substring is of even length. In that case, let's suppose what is the case over here, A, B, C, C, B, A, right? So suppose this is the substring and this is of even length. So I started I from this index 0, 1, 2, 3, 4, 5. So I value is 2. Start would somehow reach over here and would somehow reach over here, and L would come out to be 6. And start has to come at 0th index, right? So it would be I minus L by 2, which would come out to be 3, and minus 1. I minus L by 2 minus 1. And end would be updated as simply as I plus L by 2. Right, so in this way, start and end indices have been maintained, and finally, when this loop ends, it means we had considered all the elements, and each index has been taken care of by considering it as the center of the palindromic substring. So finally, we had updated the start and end variables, and basically, I have to return the substring present between start and end indices. So there is an STL function provided by C++. So it is string dot sub str. So here we require two parameters. One is the starting index of the substring, which is start, and the second parameter is the length of the string, which is end minus start plus 1. Let me run it. Compilation error gdh. Okay, string is str. Str dot, okay, semicolon has been missed. Yeah, it is accepted. Let's try to submit this code. Runtime error. Let's see what's the issue. If we are missing any test, any condition over here, start is 0, str dot length, and right is less than str dot. Yeah, one condition we missed over here is it is I minus L by 2 plus 1. I mistakenly mentioned it as like this. Run this code. I will submit it after that, and let's submit it again. Yeah, though runtime and memory usage are fine, and this is the most most efficient solution of this problem. So personally, like, I really like the DP approach of this problem, in which we created a 2D matrix. So suppose this problem is basically asked in the interview. So if you somehow come up with the DP solution, that is also fine. Like, no one expects you to have this solution presentable at the time of interview. Like, here we are saving the O of n square time, space complexity, right? So DP solution is also very good one. So I hope, like, I would recommend you to basically practice the DP solution yourself, because that solution would help you in another DP solutions as well. And whenever a problem related to palindrome comes up, try to use this kind of approach, like the center approach we have taken. So for a palindrome, if we look it from the center, the string would appear similar, it's kinds of a mirror image from the center, right? So this approach can be used in another solutions as well related to palindromes. So keep on practicing the problems related to strings, palindromes, because these are very frequently asked in the interviews. And I will see you next time. Thank you, everyone.